Good morning, students. This is Dr. K. Lavanya, Assistant Professor, Department of CSC, University College of Sciences, Acharya Nagarjuna University. So today I'm going to talk about the genetic algorithm, which is one of the important topics in machine learning. So the major contents I'm going to cover in this session is motivation, genetic algorithm, an illustrated example how this algorithm will work, hypothesis-based search, genetic programming, how this evaluation and learning will be modeled, and finally I'm going to talk about the parallelizing genetic algorithms. So first I'm moving into the motivation. So basically the genetic algorithm, which is actually motivated by the analogy of biological evolution. So that is the major concept where this learning method is introduced. So especially coming to the GAS, here the successor of hypothesis all time it will be generated by taking the part of the best current hypothesis and repeatedly it is muted. This is the major idea which is behind it to generate the successor hypothesis. So in this particular concept, a collection of hypotheses will be called as a population, and every time this population will be updated by replacing some fraction of the population by the offspring. So we can call it as an offspring, and this offspring generally will be the part of the population that may be the 10% or 20%, 30%, whatever it may be. The offspring is generated by taking the fraction of population from the current hypothesis. So this GAS is actually populated because of some of the factors. So one of the factors is this is already a robust evaluation because most of the biological systems already they are working with the genetic algorithm. That is one factor. And the second factor is whatever the searching spaces related to the hypothesis we are considering, which is a complex interacting parts. And from this, the impact of each part will be influenced to the overall hypothesis fitness. So that means we are evaluating the fitness related to the particular hypothesis based on the individual part of the hypothesis. So that is the second factor. And one more important factor is these kind of algorithms. So generally we can allow them to do in a parallel. So once if you can convert these serial genetic algorithms into parallel version, then automatically you can able to decrease the computation process, and with this you can able to increase the efficiency of the algorithm also. This is a simple motivation. Then coming to the genetic algorithm. So the genetic algorithm I'm going to be explained with the basic steps, and which is later how the hypothesis is represented in the genetic algorithm we will see. And some of the basic genetic operators also I'm going to cover. And finally, how the fitness function will be, how the selection will be, we are going to look at the fitness function and selection. So coming to the genetic algorithm. Will be the fitness function, fitness threshold, the number of the hypothesis, and the fraction of population, how you replace with the crossover for every step, and M will be the mutation rate. So these are the total 5 input parameters that will be taken by the genetic algorithm. So first we need to initialize the population. So the population initialization generally it will be done in a random way. And after that, so you have to evaluate the every hypothesis in the population based on the function so-called fitness of H. And this fitness of H all time it is depends upon the fitness threshold. So ultimately you need to retain the fitness threshold. So for that, you need to execute this process in it repeatedly. So for every new generation of the population, for example, you can see here, this is a PS, and the PS is a successor of the population, and each generation, so these 5 important steps are repeatedly performed. The first one is how many number of the select means the probabilistic selection of members P to PS. For example, if you can take P I am considering as a 100 hypothesis, and how much fraction of hypothesis that will be taken into the next successor of the PS. So that will be depends upon the probabilistic function. So the probabilistic function will be evaluated based on the fitness of the current hypothesis over the fitness of the rest of the hypothesis.